In the previous video, we had studied about the various laws of chemical combination. Okay, so this was in the 18th and the 19th century, the beginning of the 19th century, that all of these laws had come up. And at that time, the understanding about what an element was, what a compound was, all of that was relatively less compared to what we know right now. So at that point in time, there was John Dalton put forward a theory which was known as the Dalton's atomic theory. This was done to explain what they knew about the structure of matter, and like what was the information that was obtained regarding elements, compounds and mixtures, and the laws of chemical combination. All of these were combined to give us the Dalton's atomic theory. In this, it has the main postulates are 8, and the first one is matter is made up of extremely small indivisible particles called as atoms. So it's made up of teeny tiny particles called atoms. The second, atoms of the same element are identical in all respects, that is shape, size and mass. So obviously when you have an atom of hydrogen, it should be same. So if you have two atoms of hydrogen, they will be same with respect to size, they'll be the same with respect to the shape, and the mass is also going to be the same. The third rule is the opposite. So if you have atoms of two different elements, they will differ in mass, size and chemical properties. So they are going to be different with respect to their masses, their size and the experimental properties. The fourth rule said that the atoms of same or different elements combine together to form compounds. So when you have suppose you have two atoms of hydrogen. So it leads to the formation of the molecule H2. Okay, and this is commonly referred to as molecule right now instead of compound. So you have atoms, they combine together to form compounds. So it could be H2, O2. Okay, all of these are these two are examples of same elements. When you have different elements, H2O, which gets us to the next postulate, which said that when atoms combine with another to form compounds, they do so in a simple whole number ratio. And this is exactly what we had studied in our law of constant composition. Irrespective of where you get the particular compound from, the ratio of the elements will be the same. The sixth one says, atoms of two elements may combine in different ratios to form more than one compound. So here you have the simple example you can take is hydrogen and oxygen. So when hydrogen and oxygen combine, it can either give us water or it can give us hydrogen peroxide. So atoms of two elements may combine in different ratios to form more than one compound. So here you have two compounds formed, water and hydrogen peroxide. The next one is the atom is the smallest particle that takes part in a chemical reaction. Okay, and one important thing is rather than fraction, so you can't have half an atom taking part in a chemical reaction. It will be the whole atom which takes part. Okay. The last one is an atom can neither be created nor be destroyed. Now, amongst these postulates, the law of conservation of mass is visible in the first postulate and the last one. So, matter is made up of extremely small indivisible particles called atoms, and an atom can neither be created nor be destroyed. In law of conservation of mass, we learned that mass of the reactants will be, the net mass of the reactants will be equal to the mass of the products. The next one is law of constant composition, which is given from postulate number 5, which states that they combine with one another, they do in simple whole number ratio. So H2O can always be only H2O, irrespective of where you go, it will stay H2O. And multiple proportions is obtained from sixth postulate. Okay, so you have, if you haven't checked it out, do check out the video on the various laws of chemical combination, and these laws have been discussed in detail. So, but there was an issue with respect to Dalton's atomic theory. As as they started studying about the atoms and understanding it in a better light, they realized Dalton's atomic theory was no longer in basically was no longer following or showing the results that it was supposed to. Like there was new information that was obtained, and the postulates over here did not explain the new information. So there were, in the beginning of 20th century, there were various scientists who had come out with the different types of models of the atom. Like they told as to how an atom is supposed to look, and that will be taught in the second chapter, the structure of atom. But there were a few limitations or drawbacks to Dalton's atomic theory. The first one was it was able to show or explain the law of chemical combination, but it was not able to explain the law of gaseous volumes. It did not tell us why H2 plus Cl2 gave 2 HCl, and why 1 volume of hydrogen and 1 volume of chlorine gave us 2 volumes of hydrogen chloride. So it was able to explain the law of conservation of mass, but it was not able to explain the law of gaseous volumes. Next one, there was also no clarity as to why now suppose let's take hydrogen and oxygen. There was no clarity as to why the size, mass and valency of hydrogen is different from that of oxygen. Like what is the reason that they show difference in these properties was not clearly explained by Dalton's atomic theory. It was also unable to explain why compounds were forming in the first place. Like why couldn't elements stay as they were? I mean, like if hydrogen stays as hydrogen, why did it have to combine with oxygen to give us water? This clarity was not given by Dalton's atomic theory. It also, and mind you, this was in 1808 that this had come out. So they had not known how two atoms are attached to each other. So they did not understand how this was forming in the first place. So they couldn't understand the nature of force which held two atoms together to form a molecule. And the last one is the fact that there was no clarity as to what the smallest part of an element and the smallest part of a compound was. Nowadays we know a compound's smallest part will be the molecule, and the element's smallest part, if it's stable, it will be an atom. If not, it will be a molecule. I'll be dealing, or rather talking about this again in detail after we finish Avogadro's theory. So do check it out. So Dalton's atomic theory was given in 1808, which basically combined all of whatever they knew about an atom then, and he had come out with 8 postulates, which did not prove to be right, as there was more innovation in terms of how much they knew about an atom in the first place. So there were 5 major drawbacks. It did not explain why the law of gaseous volumes. It did not explain why two different atoms will have different valencies, different sizes and different shapes. It did not explain why do these atoms have to combine with each other in the first place to form compounds. And it failed to explain as to what the nature of forces were that made sure the atoms bound together in the first place. And last one, it did not give us a satisfactory explanation between the ultimate particle of an element and a compound. So with this, we finished Dalton's atomic theory. Do check out the next video, which is going to be about Avogadro's hypothesis. Very interesting. So yeah, check it out.